Hello, sweet science students. I'm trying out some new equipment and giving it a try at how I can teach with kind of a smart recording program where you can hear my voice and see what I'm writing on my smartboard. The funny thing is I can't hear you though, so if you have any troubles as we're going through this, just jot down some notes for yourself and send me a big ol' email of questions, or if I've made a funky mistake that I need to correct or anything like that. The other thing that you can do is download the key for my notes. It is on D2L, so you can download that, have a peek over, and then you can kind of work along as we're going. There should be blank copies of each section of the notes. It's not one big booklet, each section of the notes though. So if you need to reprint anything, you are welcome to. So I'll try to record little lessons. I also have some videos from a friend of mine from a couple of years ago when she was teaching Science 10. I haven't fully watched all of them, so I'm hoping they're all good, but that's kind of a second way that you can view the information if you need a little more support. And I will be posting some videos to Khan Academy or some of the other teaching websites for how you can be supported. I also have a 4-year-old sitting here that probably is going to interrupt me, so we'll be patient with him. He's playing some Goose Game on the Switch right now. So if I disappear or I seem to be talking to somebody, that's probably what's going on. So in your notes, you'll need to peek back at what we did before. Again, I have those videos posted from the friend of mine. You need to look back at what we did before spring break and before everything happened. So have a peek back, but flip in your notes package to CA4. So we had done everything up to this point. I'm not going to talk too much about it. I'm going to assume that you've looked back at those notes and you remember where we're at. So we're going to look at Bohr models. So Bohr models and energy level diagrams. So drawing Bohr models is what we're going to look at today. So Part 1 says find the atomic number. So this tells you the number of protons. We talked about that previously. You'll notice every element in the periodic table has its own atomic number. It increases kind of from left to right and down. So something, I don't have a periodic table with me, I just realized that. Something that has 15 protons will always be the same thing. So find the atomic number, it tells you the number of protons. Write the name of each element. I usually just use the element symbol actually, so the 2 letters or 1 letters depending on what it actually is. So it says in a small circle above the name, oh, I see what I've done. Write the element symbol and the number of protons. I actually also will always write and the number of neutrons as well, because that will tell us what isotope we're dealing with. Again, isotopes we would have talked about previously. Isotopes will always have the same number of protons, but will have a differing number of neutrons. A differing number of neutrons, which will give it a different atomic mass. The mass of an element is made up of your number of protons plus your number of neutrons. Remember, the mass of an electron is negligible. So this represents the nucleus of the atom. Again, most of the mass of an atom is housed within the nucleus. So find the number of electrons if we're talking about a neutral atom. So neutral means no charge. So if something is a neutral atom, your number of protons, which are your positive charges, need to be equal to your number of electrons, which are your negative charges. And so electrons, we talked a little bit about this, are placed in what we'll call shells or levels around the nucleus. And so I gave you some information previously, I'm pretty sure, flipping through my notes right now, that in the first shell, oh yes, we did. When we were talking about Bohr model stuff before, we talked about this. The first energy level or the first shell can hold 2 electrons. The next energy level or shell can hold 8 electrons. The third can hold 8 electrons, and actually the fourth can hold 18. But again, I won't ask you to really get much further than that, or really at that point, but if you want to add it on here just to help yourself, that the fourth shell can fit 18 electrons. So a couple little things to remember. The period of an element is the number of energy levels that are occupied. So something that's in the first period will have 1 energy level occupied. Something in the second period will have 2. Third period will have 3. And it also says elements in the same group, so groups 1 through 18, will have the same number of valence electrons. So what your valence electrons are your electrons in the outermost shell. So electrons are going to fill from the inside to the outside, and the only ones that are really important in terms of reactivity and bonding are your valence electrons, or the ones in the outermost shell. So it says always fill lower energy levels before higher. For levels 2 and 3, put 1 electron on each side first to a maximum of 4, and then they will pair up until they reach a total of 8 for the energy level. That makes 0 sense until I actually start drawing it. So looking at an example, a lithium atom. So when we're talking about an atom of something, we're talking about something that is neutral. So our number of protons will be equal to our number of electrons. So looking at lithium, so find lithium in the periodic table. Hopefully you have it out in front of you. If not, pause it and grab your periodic table and look for lithium. So lithium has 3, I'm going to start at number 3 up above. So it says the element symbols. So lithium is Li, 3 protons. Again, I don't have a periodic table in front of me and I can't reach one because I'm connected to my smartboard. I believe lithium is 6.91 for its atomic mass, so we would round that to 7. Remember that our mass is equal to our protons plus neutrons. So our number of neutrons would need to be 4 to add up to 7. I think it's 6.91 or 6.92. So it rounds up to 7. So that's our nucleus. So I'm going to draw a big circle around that. We know that if there are 3 protons here, we need to represent 3 electrons. So I'm going to draw our first energy level or our first shell. And there's 2 different ways that you can represent the electrons. I usually do it as little dots. So 1, you do it at kind of the 12 o'clock and 6 o'clock. Remember that the first shell can hold 2 electrons. So it has 2 in there now. So let's draw our second shell. We needed to represent 3 electrons, so we've already represented 2. So I'm going to draw my third in. So the lithium atom, again, needs to have 3 protons, 3 electrons. We know that our first energy level can fit 2 electrons. Our next one can fit 8, but we don't need 8. We only need 1 more. I was going to say something else and now I've forgotten. Oh, I was saying another way that you can represent it. I'll usually do the dots. I know that sometimes you'll see it instead as like the letter E negative. So know that that's a pretty common way of writing it. So you see there I have 3 E negatives represented for a lithium atom. So next one is carbon. Again, it says carbon atom, so neutral. So number of protons needs to be equal to our number of electrons. So finding carbon in your periodic table, it's atomic number 6. So element symbol is C. So since it's atomic number 6, it will have 6 protons. And it will have, sorry, I'm looking at multiple things. Its atomic mass is 12.01, which you would round to 12. So in this case, it will actually have 6 neutrons as well. So that represents our nucleus. Sometimes, again, another way that you'll see it is you actually see it without the element symbol in there. So sometimes your nucleus will just look like this, because actually writing the element symbol in it is a little bit redundant, because we know anything that has 6 protons is carbon. There's no other way to have something that has 6 protons. It's automatically carbon. So in terms of up here, we've said we have 6 protons, so we need to have 6 electrons. We fill the innermost shell first. So thinking, how many electrons fit in the innermost shell? That's right, 2. I heard you answer it. And the next shell, how many can the second shell hold? That's right, it can hold 8, but we actually only need to represent 4 more. We've already represented 2. So this was kind of that convoluted sentence of number 5. It says, put 1 electron in each side. So that's saying like the 4 directions, compass directions, I guess. So you put 1 on each of those, 1, 2, 3, 4. That's all we need to represent. If we needed to represent more, then you actually start pairing them up next to each other. So we would draw another circle right next to that first one, but we actually don't need it for this one. So it'll look like that. So it has 6 protons, 6 neutrons. It actually has 6 electrons, and that's a carbon atom. Next one, neon. So find your way to neon. Uh-oh, this is one that I don't have memorized. It's atomic number 10. Since we have an atom, we know that it's neutral. We need to represent 10 electrons. So this is me trying to think, and I can't. Oh my God, I'm almost close enough to reach one. Oh well. So when we would calculate out, we know we have 10 protons. The atomic mass must be somewhere around 20, or rounds to 20, because I have 10 neutrons written there. So hopefully I did that right, and it's somewhere around 20 and would round to 20. Now I need to represent my 10 electrons. So 2 fit in the first shell, and then our second shell can fit 8. Which is nice because we've already represented 2, so we need to use all 8 in the next shell. And again, they pair kind of separately. So this is our Bohr diagram for neon. Last one, if you want to give it a try before I do, just pause the video. Sodium. This one I at least remember. So sodium has 11 protons, so we'll need it to have 11 electrons for an atom. I believe sodium is 22.99 for mass, so that would round to 23. 23 subtract 11 gives us 12 neutrons. So again, that represents our nucleus. Again, that adds up to 23 in total, which is our mass number. The mass of an electron is negligible. So representing 11 electrons. So 2 fit in the first shell. Oh, hang on, I've got a 4-year-old that's interrupting my work right now. I'm back. I had to pause it. So 2 electrons in the first shell. Next shell, 1, 2, 3, 4, 5, 6, 7, 8. So we've represented 10, but we know we need to represent 11, so we need to go into our third shell and represent just 1 electron in that third shell. So that's our sodium atom. So those are Bohr diagrams or Bohr models. The next part that we will do is energy level diagrams. I probably do this less often, but it's still an important way to represent it. So these are the steps from bottom to top. So at the bottom you have the atom name, then you have the atom symbol and the number of protons. Then you draw a horizontal line. Then you write the number of electrons that are in the first energy level, draw another horizontal line, draw any electrons that are in the second energy level if it's used, draw a horizontal line, and then draw any energy or electrons that are in the third energy level. That doesn't make any sense until you see me do it. So let's do this for magnesium. Is that one that I did on the last page? No, it's not. So magnesium. So this is kind of step one. We have the atom name. Then you write the atomic symbol or the atom symbol, which is Mg, and the number of protons. Then you draw a horizontal line. So we know if we're talking about a magnesium atom, we need to represent the same number of electrons as our number of protons. So we know that 2 electrons fit in the first energy level, horizontal line. How many are in the second one? 8 can fit, and we need to have 8 because we're trying to represent 12. And then another horizontal line. And then we've represented 10 in total. We need 2 more. So we have 2 electrons in our third energy level. And so that's our energy level diagram. Similar, just no circles. On to the next one. So carbon atom, oh no. So carbon atom, so carbon has 6 protons. If we're talking about an atom of carbon, we need to represent 6 electrons. 2 can fit in the first shell. 8 can fit in the second shell, but I actually don't need 8. I only need 4. So in total, we've represented 6 electrons. That's carbon with 6 protons. You'll notice that in energy level diagrams, it doesn't talk about the number of neutrons, so that doesn't give you any isotope information, but that's not really important when we're talking about energy level. So neon is the last one. So neon with 10 protons. So we know again, 2 electrons fit. Trying to represent 10 electrons related to our 10 protons. So 8 electrons in the second shell. And that shell is filled. So just to read that last little blurb there, it says, according to Bohr, electrons orbit the nucleus in fixed energy levels, and each energy level can only hold a certain number of electrons. As we go across the periodic table in each period, we can see that the number of electrons increases based on the atomic number. As we add electrons, we fill energy levels until the energy level is full. At this point, the outermost energy level is complete and the atom is stable. So something like neon that we saw previously, remember the second shell can hold 8 electrons. Neon that we have there has 8 electrons. So it is stable. And if you did your energy level diagrams for any of the noble gases, so any of your group 18, you would find that they have a full outermost shell. So when we look at the number of electrons in the outermost energy level for each group on the periodic table, we can see that the number of electrons in the outermost energy level will be the same. This is true for groups 1, 2, and 13 through 18. So the transition metals are sometimes a little bit funky. We won't use that as kind of anything. Sorry. The outermost occupied energy level is called the valence energy level. The electrons in the outermost occupied energy level are called valence electrons. And so valence electrons are the important thing in terms of bonding. So if I just look back, these are my valence electrons, these are my valence electrons. Ones that are in the more inner shells are not important in terms of the bonding capabilities of an element. It's the outermost ones that have the most going on with them. So I'll write you some instructions about what you need to do with this lesson. Thanks, guys.